Hi, welcome back. It's Math with Patrick. Today is January 26th, and we have the 26th problem from this Daily Epsilon calendar to solve today. Alrighty, let's try it out. So it looks like it's another arithmetic problem, kind of like yesterday, and I have a 5 factorial multiplied by some fractions being added and subtracted. Once I do all of this math, apparently the answer is supposed to be 26. Okay, I guess one thing I could do is just follow order of operations and do the fraction addition here, and then evaluate the factorial, and then multiply them together. And I guess I'll do that first. Well, my other idea is that I could keep things in factored form and think about distributing it. Maybe that would make my arithmetic a little bit simpler. I'm not sure just yet. So how about I'll just do it the nice standard order of operations way. I'll just rewrite 5 factorial here. I'm just rewriting the whole problem actually. 1/4 minus 1/5 plus 1/6. When adding or subtracting fractions, it's really important to have the same denominator or a common denominator, and it needs to be the least common multiple of all of these numbers. So for example, if I was adding 1/4 and a 6 together, then a 24th would be, or 24 would be a really good denominator because it's the least common multiple of 4 and 6. As in, if I count up by my 4s, so 4, 8, 12, etc., I'll eventually get to 24. If I count by my 6s, same thing. Wait a sec. Actually, sorry, no, it's 12. I'm glad I did that. 24 is still a common multiple, but it's not the least common multiple. Wow, that's actually 12. I'm surprised I didn't spot that. Okay, so if I were adding 1/4 and a 6th, I would choose 12 as my denominator. And then I can just kind of look at the 1/5 and the 1/12 together. Those don't share any common factors, and so multiplying them actually is the right thing to do to find their least common multiple, and that's going to be 60. Okay, so the 5 factorial, I'll keep that there for now, and all of these need a new denominator of 60. Okay, this one's the easiest for me to take a look at. I know that 6 times 10 is 60, so I'll put a 10 up here. I think it's, 5 times 12 gives me 60, so I'll put a 12 here. And then 4 times 15 gets me to 60. Okay, there we go. So now if I'm adding and subtracting fractions with the same denominator, all I need to do is add or subtract the numerators. From the first two, I see a 3. And then from the last part, I see a 10. And so altogether, this gives me a 13 over 60. Okay, so at that point, I have simplified all of those fractions as far as I can. I can't reduce here because, well, 13 is prime, and it doesn't go into 60. So at this point, I need to start figuring out what 5 factorial is. And just as a little definition, the factorial of a number, it tells you to take the number itself, so 5, and then multiply it by the factorial of the next lowest number. Okay, well then 4 factorial is 4 times the factorial of the next lowest number. Or in other words, the factorial operator tells you to multiply all of the successively smaller integers until you get to 1. Then you can stop. The factorial doesn't really work for negative numbers as far as I know. And 0 factorial is just kind of defined to be a 1. It seems like maybe should it be 0, maybe should it be 1. The way I'm interpreting it is that I'm doing no multiplication. I have no factors to multiply. I'm counting down by nothing being multiplied. And it's just that 1 is your do nothing number for multiplication. Because if I do 5 times 1, it's still 5. And so 1 is a better representative of no multiplication than 0. Okay. Knowing 0 factorial wasn't really that important for this video. All we really need to do is figure out what this is to know what 5 factorial is. Multiplication is commutative. That means you can scramble up the order of your multiplication and it won't change your product. And that helps me here because 5 times 2 is 10, and it's just a little bit easier to work with tens when you're multiplying. 4 times 3, I guess 4 times 3 times 1 is 12. And then finally, when you multiply 10 and 12, you get 120. So 5 factorial is the same as the number 120. I'm multiplying that by 3/60ths. And I notice here that the 120 and the 60, they're going to turn into a 2 together. If you want, you could maybe think about it as like fraction multiplication. And when you have some common factors on the top and bottom, in this case 60, those can cancel out. So the 120 and the 60 together make a 2, and then 2 times 13 gives me 26. And that is today's date. So that's it for today. Just a little bit of arithmetic to confirm that what we have on the screen indeed is just the number 26. Okay, see you tomorrow. Bye-bye.